Somebody say Ryzen AI Max Mobile Workstation? HP. It's the Zbook 14. Let's take a look. We've crossed some kind of Rubicon when you can get a laptop with 128 gigs of memory. This is a mobile workstation. Now, the Zbook 14 has a bunch of different configurations. My configuration here is shipped with Windows, but you can also get it with Ubuntu, so that means that HP has done a lot of support and qualification for this machine for Ubuntu, Linux in general, but you can also get it with FreeDOS in case you're going to bring your own operating system. But yeah, up to 128 gigabytes of memory, up to 8 terabytes of storage, and if we look at our port configuration on the side, we got Thunderbolt and a USB Type A. Type A is a 10 gigabit port and can also do power delivery for charging, a Kensington lock port, and then on the other side we have a USB Type-C 10 gigabit and another Thunderbolt port, combination headphone microphone port, and a full-size HDMI. If you're the person in the focus group who decided that you really needed to print much larger alphabetic characters, like the legends on the keys should be 50% larger, I'd love to hear from you. I'd love to know more about the details of that focus group. It's like, so we really just need to make the labeling much larger, make it easier to see. Boom, our system is booted up and ready for testing. So I gotta copy a bunch of stuff to it, but this is the full 128 gigabyte configuration. Make no mistake, multiple terabytes of local storage, a brilliant OLED screen, which is really pretty amazing. It is a touch screen as well, so it's glossy, so it's easy to clean your fingerprints off. 128 gigabytes of memory. Have I said that? That is breathtaking. The 8060S for the GPU, so this will game like a laptop with a discrete GPU, even though it doesn't have a discrete GPU. This is, I can't wait to get to that. AI and AI workloads, running those mobily, not just on the NPU. I mean, this is Ryzen AI. The AI there means that there is a neural processing unit. The NPU is really about low power AI. But with 128 gigabytes of memory, you're going to be running your AI mostly on your 16 CPU cores and your 8060S GPU, which is more than above average GPU horsepower. It's really something to have this much computational horsepower in a laptop this small. I mean, this is a thin and light of 3 or 4 years ago, and the fact that it has 128 gigabytes of memory, a ridiculous GPU, ridiculous GPU capabilities, plus an AI coprocessor, plus everything else, technology's moving fast. All right, I've been using this thing for the last couple of weeks. I put some serious mileage on it. This is the future. Like, AMD and HP have put something together here that is beautiful, that is so far beyond and away from what I thought you could get in a thin and light mobile workstation. And thin and light is almost, I mean, historically that's been a derogatory way to describe it. This would have been referred to as a thin and light laptop just a couple of years ago, but it really is a workstation class laptop. Like, think giant brick that weighs 20 pounds. Those kinds of workstation laptops, but in this form factor. 128 gigabytes of memory and a GPU that is breathtakingly awesome. Better than a dedicated GPU in a lot of cases. AMD's really hitting their strides with the AI Max CPU, and HP has built a beautiful machine around that processor. I can hardly believe it. I mean, this feels like something out of science fiction, like someone came from the future and dropped off this laptop. 2880 by 1800, 120 hertz. This is the most beautiful, gorgeous laptop display that exists in the market. Like, this is the benchmark. This is the thing to look at to see, oh yeah, all other laptop displays should be this good, or measured against this. If you do want to run this laptop full tilt insanity, you can drain the batteries in 45 minutes, but even with reasonable settings for the battery, you're not going to kill the battery in under 2 hours. So most of that stems from the monster built-in GPU. It's an APU, so it doesn't have a dedicated GPU, which is great in terms of power management efficiency and that sort of thing. But the GPU in here is a monster. It's 40 compute units. And yes, you can run AI on that. I'm not talking about the AI coprocessor, which this also has, and you get 40 trillion operations per second with that. But I'm talking about the actual GPU, which it's good enough you can game on it and get 60 FPS at medium, high at 1080p, which is absurd. And we'll talk about that more in a second as well. This thing comes in at under 3.5 pounds. So like I say, thin and light. It also It is a 140 watt power brick, and you might be alarmed because it's like, wait a minute, 140 watts. Well, that's the thing here. I actually like this about AMD for their processor. I'm gonna blame / praise AMD for the configuration here, and what I mean by that is 16 cores. And if you let 16 cores drink the power plus 40 compute units, this thing is basically desktop class performance, period. And you can use those USB 4 connections to connect external PCI Express connections, turn it into a full-fledged dock. You can, you can go nuts with the HP. I think the G6 dock would pair best with this. I did test it with the G5 dock, but I think the G6 dock would pair best with this because you got, the 20 gigabit USB plus 40 gigabit USB 4 plus the tunneling plus external stuff. If we dive right into the benchmarks and take a look at, just get a baseline from CPU-Z. About 800 points single thread and about 11,000, 10,700, something like that for the multi-core score. That's the Ryzen AI Max Pro 395 with the Radeon 8060S. This is 128 gigabytes of LPDDR5, and the timings were pretty good: 25, 18, 21, 42, 63. It should also be noted that Windows is such an odd operating system, and it is different than Linux in terms of shared VRAM. So like architecturally, the GPU and the CPU use that same pool of 128 gigabytes of memory. And historically, it made sense to reserve 2 gigs or 4 gigs or 8 gigs or 16 gigs of system memory for the GPU, and then you had the rest of the memory for the system. But software people that are looking for optimizations rightly looked at that and said, well, it doesn't make sense for, say, a game to load textures into system memory and then copy that into video memory, which is normally what you would do when you have a dedicated device, because the video card has its own onboard high-speed memory, but that isn't really the case here. The GPU could physically access system memory without having to do that extra copy. And we haven't quite figured that out in terms of the driver architecture and everything else. This is unified memory. Apple sort of famously has figured that out with the unified memory, and they have done some different things as far as the memory bus, that sort of things. But AMD has done a lot of deploying and engineering to unlock that kind of functionality. And to be clear, that functionality is more present on the Linux side of things than the Windows side of things. Out of the box, this thing came configured for 512 megabytes of VRAM. I think the system engineers expected the software to be 100% ready to go with that unified memory aspect, because theoretically, for games and AI and everything else, the AI and the game could use all 128 gigs of memory, and the GPU would be able to seamlessly and effortlessly access all 128 gigs there. But it did make a bit of a difference in the benchmarks depending on what I was benchmarking, because it seems like some software is able to use the unified memory architecture and some software was not. So it is possible to go into the BIOS and configure this thing with more VRAM. And so if you get this system and you're on the Windows platform, I would recommend that you make the change from 512 megabytes to 8 gigs, maybe 16 gigs, especially if you get the 128 gig configuration. The 128 gig configuration may be a little overkill. 64 gigs is probably fine unless you know what you're doing. But being able to run 70 billion parameter models on this at more than a couple of tokens per second is kind of nice. So 128 gigs of memory may be worth it. All right, first up, AIDA64. If we take a look at this, the latency number, 161 nanoseconds. Oh, I wish it was better. The latency is a little variable here depending on power settings and some other things. It seems like it will step down into a lower power state, and the benchmark isn't benchmarky enough to keep the system from going into a lower power state. So while I wish 161 nanoseconds were better, this is not terrible given the context of this system and low power and everything else. What is remarkable is that we're at 118 gigabytes per second read and 169 gigabytes per second write. These are phenomenal results for a mobile system. We also have our battery report test, which I'll just cover really quickly. This is a 75 watt hour battery design according to the battery report, but our full charge capacity is only 70 watt hours. And for the different kinds of benchmarks that we do, you can run the battery down in as little as 45 minutes. Even a strenuous, and that's an artificial workload, like a truly fully strenuous workload, you're still going to have an hour and a half, 2 hours, something like that. And I would say that like a typical work day where you're actually using the machine all day continuously, you can get about 7-8 hours. If you're using the machine in a light configuration, again, you know, upwards of 10 hours is not unreasonable. Cinebench 2024, a single thread score, 112 points, and our multi-core score, 1500 points. That's pretty good scaling and pretty good overall performance. This is plugged into AC, however, so, you know, it's using a lot of power. Geekbench, 2700 points, single core, and 14,000 points multi-core, almost 15,000 points multi-core. And if you look at the specific results, Strix Halo is a monstrous little machine. I mean, if you look at the specific benchmark results in Geekbench 6, there are some strong outliers there. AMD has done a lot of engineering on this processor to give it a lot of horsepower, but still be relatively power sippy. Our Geekbench OpenCL GPU result is 77,738, which is pretty respectable, all things considered. PC Mark battery testing for gaming was about an hour and a half, and I would say this lines up pretty well with my real world experience. So Shadow of the Tomb Raider, running at 2880 by 1800 on high with DirectX 12, 65 FPS. 65 FPS, and keep in mind this is an APU system. It doesn't have a dedicated GPU. So when I say that, yes, this is as fast as, you know, a laptop that has a 4000 series dedicated GPU, but this is also a business class workstation, so you can run business class software. This is a monstrous little GPU that's built into the CPU. 40 compute units, an 8060S Radeon, so that is a different and apart from the other built-in GPUs that you normally have in an APU. Usually it's something like a, you know, an 860M or something. This is an 8060S. It's a completely different built-in GPU that is absolutely monstrous because it can do 60 FPS on high at 2880 by 1800 on this gorgeous screen. Counter-Strike 2, we benchmarked Counter-Strike 2 because why not? And this is a really impressive result for Counter-Strike 2. Counter-Strike 2 can overrun your 120 Hz refresh on the display. Woo! Cyberpunk 2077, a modern title like that, on medium balanced, 64 FPS. Final Fantasy Dawn Trail, fairly high at 7,314. Monster Hunter Wilds, if you ditch frame generation, you're going to go down to about 54 FPS, but because this display supports variable refresh, it's still very playable. So AI benchmarking on Windows is a little strange. ROCm is what we need to unlock maximal performance and understand that this is running on the GPU and the CPU, and you've got 16 cores to work with, but you've also got 40 compute units on the GPU side of things, which is monstrous. And then you also have the AI accelerator that's built in for certain kinds of AI. So depending on what sort of a model you're running, you may be able to run your model on the low power 40 tops thing, but more often than not, if you're doing research or working on your own things, you're probably running on CPU GPU land, which is going to use a lot of power and be a little bit of a different experience than running on the AI TOPS accelerator, the NPU, the Neural Processing Unit. So these benchmarks are the Windows benchmarks, but we'll talk a little bit about some Linux benchmarks, which maybe give me a little bit more hope for the future. So Gemma 3, a 1 billion parameter, it's a 48 tokens per second. And the prompt that I like to use for benchmarking is consider everything you know about perfect numbers and write an efficient Python program to search for perfect numbers. Gemma 3, 4 billion parameters, down to about 17 tokens per second. Gemma 3, 12 billion, about 6.8 tokens per second, all the way down to the distilled DeepSeek models. The DeepSeek Llama 70 billion parameter model was just 1.24 tokens per second. With LM Studio and some of the ROCm tuning, the best that I could pull out on the Windows side of things with DeepSeek R1 obliterated, that's a 70 billion parameter model in Q8, was about 2.66 tokens per second. So on a 70 billion parameter model, it's more than twice as fast with optimizations and some custom configurations in LM Studio. Now on Linux, Ubuntu 25.04, basically everything works except the camera and the MediaTek Wi-Fi. The MediaTek Wi-Fi leaves a lot to be desired. I was going to complain a lot more about the MediaTek Wi-Fi, but just in the last couple of weeks that I've been working on this laptop, there have been one firmware update and a couple of patches to the Linux kernel that resolved a lot of the outstanding issues with the MediaTek Wi-Fi. The secret to the MediaTek Wi-Fi in this particular laptop is that it seems to only be able to join one network at a time in Linux. I'm thinking about doing a separate guide, like a setup guide video for ROCm and Linux. I went down a little bit of a black hole with the Windows subsystem for Linux and seeing what sort of a developer workflow that would be with the AI stuff. The Windows subsystem for Linux for basically everything else is 100% solid. It's very nice. This is a very nice dev platform for native development, as well as the Windows subsystem for Linux. It works great, 16 cores, 128 gigs of memory. You will want for nothing. It will be like computing from the future. It's really, I mean, 3.5 pounds and 128 gigs of memory. It really does feel like somebody came from the future and said, here you go. This is, you know, an incredibly advanced device. I wish they'd brought the drivers, however, with 5 years of development and everything else on the Linux side of things. On the Windows side of things, you can definitely tell that HP has also put in a lot of time on the engineering to try to make sure that the experience is just so. And so right now, the Windows experience on this laptop is considerably better than the Linux experience. Over the course of 2 weeks, having Microsoft Office 365 open and Teams and Outlook, there are a couple weird things that happened. Some of that may be down to a Windows update, some of that may be down to just Teams. I think Teams at one point thought it was still in a call, so when I closed the laptop, it never actually went to sleep. And looking at the power usage report, you can run power report. Windows actually has good tools for debugging this kind of thing. It was like, why didn't the laptop sleep, Teams? I don't want to quit Teams whenever I close my laptop, but good Lord, I can't blame HP or AMD for that kind of a thing. And I have a feeling that some of that to do with connected standby is part of it, because suspend and resume on Ubuntu 25.04 was a dream. It is hard to get suspend and resume to work correctly on those platforms, and you do have to, like, ideally, I like the idea of being able to set it so that when the laptop goes to sleep, after it's been asleep for like an hour or two, it will hibernate. I'm Wendell, this is level 1. This has been a quick look at the HP G1A, 128 gigs of memory, Ryzen AI 395 Max. This is the most impressive CPU from AMD and a very impressive platform that HP has built around it that I've seen ever. It is like these devices are from the future. AMD is really hitting their stride, and it is nice to see partners like HP look at that and say, yes, you've got an engineering win on your hands. We're going to bring our A game and build a really nice machine around it. It's very nice to see. If you want to see something specific on this machine, let me know. I've got it for a couple more weeks. I really want to do that Linux video, but I want to know what sort of direction to take it in, so engage below or hit me up in the forum. I'm signing out, and I'll see you there.